Well, hello there. So here is our next rule. So this is the power rule. So we've seen this before, but once again, just to recap, just to give a quick review, our power rule, here is the math, all right, behind it that says if you have this x, this variable, whatever it is, and it's raised to the power a, and then I'm going to take that whole expression and I'm going to raise that to the b power. That I can really simplify that and just say that that will be x to the power of whatever a and b when we multiply them together, whatever number we get for that. This is probably one of the easier powers that we have to deal with because we're just multiplying things. So let's take a look over here, number 11. If I have x squared and then I want to raise that whole thing to the 0 power, that's the same thing as saying x to the 2 times 0. And you're thinking to yourself, okay, well 2 times 0, that's just 0, so this turns into x to the 0 power, and we know that anything to the 0 power is, of course, 1. Alright, and that's our answer. Sounds kind of weird that we could start off with this problem over here and end up with 1, but that's what our rules tell us to do, so we don't worry about that. We just follow what the rules say to do. Alright, let's look at number 2. Most common mistake that we will make is going to be on a problem like number 12. Okay, we see how many terms inside the parentheses. Most of you might have said 1. I would argue with you that we probably see 2 terms. I see a 2 and I see an x squared. You have to remember x squared, right? That is x to the 2nd power. Well, 2 is really to the 1st power, but I don't write it. And my power rule says no matter how many things you have inside, all right, you have inside this parenthesis here, each one of them will be raised to the power of -4. So let's see that in action. So let's do the same thing we did before. So we're just going to multiply our powers. So 2 is to the 1 times a -4. And our x's turn into 2 times -4. Okay, well let's simplify this down. So 1 times -4 is -4. 2 times -4, that's -8. So I'm left with 2 to the -4th, x to the -8th power. Let's say the problem said, hey, write this with just positive exponents. Okay, if it didn't say anything about positive exponents, we could be done right now. But we're going to go ahead and say that it did for the sake of argument, because most of the time it will want us to write this like it is. Well, here's what I can say. I can say, so right now I have 2 to the -4th, and I have x to the -8th. And if it helps you, think of all this as a fraction. I want to move anything with a negative exponent from wherever it is, in this case it's in the numerator, down to the denominator. Okay, so I need to move actually both parts of these things. So this has to move down here, alright, as well as this part has to move down here. So we would write this as 2 to the 4th and x to the 8th. And now you're all probably wondering, well, what do we put right here? Well, easy enough. We are just going to put a 1, guys, okay? Don't make this any more complicated than what it is. So these two things right here mean the same thing. 2 to the -4th power, x to the -8th means the same thing as what I've got right here. All right, let's create a little bit of room, all right, for our last couple problems here. All right, never mind me. I'm just going to get rid of this here. And let's look at 13. So 13 is 4r to the 0 power, and then we are raising this entire quantity to the 4th power. How many terms do I see? I see this one right here. I also see this one. 4 is raised to the 1st power. You are correct. We're not going to do anything differently than what we did last time. We multiply our exponents. Okay? We'll multiply our exponents. 4 is to the 1st power. Okay, this is where I got the 1 from. This is where I got the 4 from. We multiply those two numbers together. 1 times 4, and that turns into a 4. Okay, r. Well, I'm going to use I'm going to use the 0, as apparently I'm not writing in red anymore. So we're going to use the 0, and we're going to multiply that by the 4. 0 times 4 is just 0. Anything to the 0 power, of course, is 1. So all of this turns into 4 to the 4th power. All right, let's look over here. So this is 4a cubed, and I'm going to square that whole thing. All right, maybe you guys don't believe me with the fact that even though we see two things in here, all right, that both of them get squared. Because a lot of times, if we're going to make a mistake, all right, here's what it's going to look like. You're going to give me this answer right here. You say, yep, this is 4a to the 6th power, Mr. Fricky. It's got to be. Has to be. And I'll say, you know what? I agree with you with this part. All right, this part checks out. That's good. But we forgot the 4. All right, now remember, when we square something, what does that really mean? So if I take 4a cubed and I want to square it, that just means I'm literally going to multiply it by itself again. All right, so if I had this problem now, right, if we had this right here, well, isn't this just the same thing as product rule? What we did, all right, on one of our other videos? I believe that it is. Okay, look, I've got the same base here. I've got the same base here. Same base here. Same base here. So keep your base and add your exponents. That's a 1 and that's a 1. Keep your a's and add your exponents. So what does this turn into? This turns into 4 squared, which we know is 16. And a turns into what? A to the 6th power. All right, now let's look back. Let's compare that with our answer we got over here. Now remember, this is the answer that you gave me that was only half right, because when we forget about this, our number, all right, right here is never going to be right, because really this is 4 to the 1st power. And power to a power says you have to multiply this 1, all right, by this 2. So really we should have a 2 here. And if this is 4 squared, well, that's the same thing as saying 16, right? And then a to the 6th. So, guys, just another way for us to get the same answer, but hopefully it drives home that point. All right, why don't you go ahead and give 15 and 16 a shot here on your own. I'm going to challenge you to write number 16 with positive exponents, not negative exponents. So give those a whirl, come on back, and we'll see how you did. Okay, so you are back. Everything is right in the world again because we are doing exponent problems, which we all love. And I'm just going to breeze through these. I see two terms. All right, in our first one I see this 3. I also see a k to the 4th. I know that this is 3 to the 1st, and I'm going to multiply that by 4. Or say, hey, that's got to be 3 to the 4th. K is to the 4th power right now, and I'm multiplying that by another 4. Because here's my two 4s. So this is k to the 16th. And we're good here. We could simplify 3 to the 4th, right? That's just 3 times 3 times 3 times 3. I think that works out to be 81. If we wanted to do that, we could say 81k to the 16th power. They both mean the same thing. And lastly, let's look over here. So I've got 4x and y. And I'm going to raise everything here to the negative 1 power. So, hey, that sounds great. Let's see what we can do. So, all of these right now, 4 is really raised to the 1st power. I know that x is raised to the 1st, and if you haven't figured it out, y is raised to the 1st as well. My power to a power rule says we must multiply our powers together. So, this is a 1 times a negative 1. My x, same thing, 1 times negative 1. And my y is a 1 times negative 1. Or all of these are now to the negative 1st power. And I challenge you to write these with just positive exponents. Actually pretty easy. Okay, we know we're going to have a fraction. If these are all negative, they are all literally just going to go into my denominator. And so I can say 4x y, because they're all just to the 1st power now. And I can say that this is all over 1. Good job.